When explaining Bayesian statistics to people who don't know anything about stats, I often say that MCMC is about walking many different paths in lots of parallel universes and then counting what happened in all these universes. And in a sense, this whole podcast is dedicated to sampling the whole distribution of Bayesian practitioners. So for this episode, I thought we'd take a break from pure hard modeling and talk about how to get involved into Bayesian statistics and open source development, about how companies use Bayesian tools, and about what common struggles and misperceptions the latter suffer from. Quite the program, right? The good news is that Peadar Coyle, my guest for this episode, has done all of that. Coming to us from Ireland, Peadar is a fellow PyMC core developer and was a data science and data engineer consultant until recently, a period during which he has covered all of modern startup data science, from A/B testing to dashboards to data engineering to putting models into production. From these experiences, Peadar has written a book consisting of numerous interviews with data scientists throughout the world, and do consider buying it, as money goes to non-focus organization, under which many Bayesian stats packages you love live, like Stan, RVs, PyMC, etc. Now living in London, Peadar recently founded the startup Aphorismic, an AI solution that aims at developing personalized voice-first solutions for brands and enterprises. The technology is also used to support children, families, and elderly coping with the mental health challenges of COVID-19 confinements. Before all that, Peadar studied physics, philosophy, and mathematics at the universities of Bristol and Luxembourg. When he's away from keyboard, he enjoys the outdoors, cooking, and, of course, watching rugby. This is Learning Bayesian Statistics, episode 32, recorded August 20, 2020. Welcome to Learning Bayesian Statistics, a fortnightly podcast on Bayesian inference, the methods, the projects, and the people who make it possible. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country, and reach a true Bayesian state of mind by visiting learnbayesstats.com. That's learnbayesstats.com. Do you want to support the podcast and unlock exclusive Bayesian swag at the same time? Then you can visit my Patreon page at patreon.com/learnbayesstats. Starting at €3, you can get various benefits like the private MBS Slack channel, early access to special episodes, selecting questions for episodes, or even coming on the show. You'll get more details at patreon.com/learnbayesstats. Thanks a lot, folks. I'm very grateful for any support you can bring me.
Let me show you how to be a good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations.
What's a Bayesian? Is someone who cares about evidence and doesn't jump to assumptions based on intuitions and prejudice. A Bayesian makes predictions on the best available info and adjusts the probability, cause every belief is provisional. And when I kick a flow, mostly I'm watching eyes widen, maybe cause my likeness lowers expectations of tight rhyming. How would I know unless I'm rhyming in front of a bunch of blind men, dropping placebo-controlled science like I'm Richard Feynman? Is it because of my looks or the fact that I talk like I'm mad for books? Either way.
Hello, my favorite Bayesians. Before hearing from Peadar, I want to personally thank Nathaniel Burbank for supporting the show on Patreon. This helps me pay for editing, for new content, and that really helps the show in general. So thank you all for your continued support. Speaking of patrons and new content, I am delighted to announce that I'm starting a new format on the podcast called Matchmaking Dinners, where two former guests have an informal conversation about Bayesian stats topics they are currently interested in, as if they were having dinner. The first installment is coming soon and will feature Will Kurt from episode 16 and Junpeng Lau, who was on episode 7. Does that sound interesting to you? Well, of course, it's about Bayes, it's about food. What's not to like, right? So make sure to take a look at patreon.com/learnbayesstats, as this new format will be exclusively for patrons of the show. And I know the coming guests and I are really excited about this new format, and I hope you are too. Of course, feel free to reach out if you have guest pairing suggestions for future episodes, and keep the feedback coming once episodes are out. A new format always has more chances to evolve at the beginning, so do get in touch. On that note, let's talk about open source development and Bayesian industry with Peadar Coyle. Peadar Coyle, welcome to Learning Bayesian Statistics.
Thank you for having me, Alexander.
You're welcome. It's always great to host a fellow PyMC developer.
Yeah, I think it's worth pointing out that I haven't actually done a lot of PyMC 3 stuff in the past year or so, because we'll get to it later on about my startup, etc. But it's a really exciting project, and I'm glad to see other people take it on further after from the stage that we got it to whenever I was involved. More heavily.
Yeah, but I'm guessing you know the software pretty well, as we'll discuss later in the show. But let's start with your story, as I do with every guest. So I noticed you started with physics and then you went into mathematics. So what's your story there?
So I started studying physics and philosophy at Bristol. The reasoning behind that is probably worth giving a bit of context, because depending on the audience, philosophy means different things. Mm-hmm. So philosophy in the French tradition kind of means like the meaning of life, etc. It wasn't that kind of philosophy. It was more like logical, foundations of computer science, foundations of mathematics, etc. And I was attracted to that because I think naively I thought if I'd studied 2 really hard subjects, I would learn everything. This is how I thought at the age of 18. But interestingly enough, and back to the whole PyMC3 thing, I had my first exposure to Bayesian Statistics in philosophy class. We had a class, I don't know what it was called, actually, I can't remember. We had a class like about decision making, and it was like, using Bayesian, and we had to build Bayesian models, and we built Bayesian networks and stuff like this. So that's quite a long time ago now, actually, because I'm getting old. But that's where I started. And then I went to teach for a couple of years in Ireland, where I'm from. And I enjoyed the teaching part, but I didn't enjoy the bureaucracy part.
What did you teach, by the way?
I taught physics and mathematics.
Okay.
Yeah. So so that's what my teaching stuff was. And then I went to do my master's in mathematics in Luxembourg, actually. That's where I ended, of all places. But that's a different story. That's kind of my story. Sorry, did you have follow-up questions to that, or is that as far as you wanted to go?
Up to you, honestly. That's always interesting to hear the different backgrounds of guests. And I'm also interested to understand why, in the end, you ended up being more interested into the mathematics side of things, and maybe why you didn't pursue physics per se in masters.
Whenever we look back at our lives, I think we can very easily invent stories or narratives. We can very easily fall victim of what like Nassim Taleb called the narrative fallacy. I think some of my reasoning was I found physics to be. So I found myself more interested in the theoretical physics side of things and the computational side, right? So a lot of my work would have been on building simulations, writing MATLAB code, etc. So like there would have been a lot of computer work, which I think a lot of modern science is. I think physics as a discipline strikes me as has hit a bit of a wall. Like it's quite difficult to figure out the progress, what's coming next. We've kind of had string theory for like a number of years. We've kind of, although there are many areas of physics that have been pushed forward, it kind of felt like a bit of a stagnant discipline, or discipline in need of a breakthrough, which I think, but maybe that's how people feel about any discipline, right? So I think after 3 to 4 years of studying. And I was always interested in the kind of big data and data mining stuff. So like a lot of my attraction to mathematics was to more statistics stuff. So a lot of that came to that. That's kind of where my own story was.
I see a lot of guests doing the other way around, like being into very theoretical mathematical work and then wanting to go into more applied stuff, so it would be like going from mathematics to physics and not the other way around. So that's why I was interested in asking you this question.
There's always different people doing during different journeys, etc.
And maybe before more into the statistics weeds, I'm curious about the philosophy side of your background. What did you enjoy the most in this education?
I enjoyed a lot of the philosophy of science stuff.
Yeah.
Because So I think it's very easy to have like this naive impression that like science is truth. And, like when you study like the philosophy of science, you realize that's not quite true. And you kind of think more about like a meta level.
Yeah.
It did become a little bit frustrating though, because it kind of, you kind of end up with all these different fields, and then you're kind of reading like quite academic tense stuff when you're kind of like arguing over splitting hairs, etc. So I think probably the most useful stuff, a lot of my philosophy stuff I studied, I found I got a lot out of the introductory classes, and I found the more advanced classes I find very academic and terse and like harder to get something out of. But that's my own impression as such. And I quite enjoyed logic, like mathematical logic classes, which were also taught, because they were, that's quite close to programming and mathematics, etc. So I find a lot of that stuff quite interesting.
Yeah, that is definitely related actually to statistics. I feel that studying epistemology and philosophy of science kind of naturally lead you into statistics, and especially Bayesian statistics, as you said earlier, because it's often related to how do you think rationally, how do you incorporate your epistemological uncertainty about the world and so on, and how do you think probabilistically. It's definitely super interesting.
Yeah. There's definitely a lot of overlap, I think. Yeah.
If I had to go back in time and talk to my past me, I would definitely tell him to study more epistemology and philosophy of science, because it's super interesting, and I think it really helps also having a big picture of a statistical work, and not being only into the programming and weeds.
Agreed.
Yeah. So let's try to invent a time machine quite quickly so that I can do that. Speaking of stats and so on, did your master in mathematics was your master in mathematics already focused on statistics more or less, or was it more theoretical? And then if you picked up statistics on your own, well, how did you end up in the stats and data world?
So I wrote my master's thesis on like stochastic processes. So that's like statistics probability theory.
Okay.
I can't remember if we did many statistics classes. I definitely remember us doing like some papers where we read, kind of like papers of things like maximum likelihood estimation and stuff like this, like the original papers of those sort of things. So my first exposure to, I guess, like professional Bayesian statistics came from Thomas Vecchi, because he came to Luxembourg because he was living quite close at the time. I think he was living in Dusseldorf or Cologne.
Ah, yeah.
And he had and he gave like a lecture on the local group, PyMC3, and applied Bayesian statistics. And I think I got first into PyMC3 or something at that time. That was a couple of years afterwards. I was working as a data analyst at Telco, telecommunications company. So in terms of like how I taught myself statistics, I think there's kind of a fundamental journey that you kind of need, that I went on personally in like the kind of data science world. So I think originally I thought like everything was about applying, fancy time series models or fancy Gaussian processes or like some sort of advanced machine learning. And I picked up a lot of machine learning from books such as Elements of Statistical Theory by Hastie et al., but largely from reading it myself, right? So, and then I think I discovered through jobs or like, so I had an internship at Amazon, and I discovered that a lot of professional data work was SQL, right?
Yeah.
Like it's almost like one of those things that I think academia doesn't necessarily prepare you for, because I think academia sort of like, you did, all the programming classes I did was like, here's a data set from UCI Irvine.
Yeah.
And you apply a model and you apply model models. But the reality is that like professional data work is almost like, and counting sounds a bit simplistic, but counting is actually difficult, right? Coming up with a denominator and numerator for a particular metric is actually quite a lot of work. It can involve a lot of connecting data sources. So then I think I probably spent like a couple of years professionally doing a lot more like kind of software engineering, database administration, like data analytics as such. And then I got more interested in open source software and wanted to contribute to open source software. I've written some pull requests for like the likes of Pandas, etc., which was a lot of my work. And then, Thomas came and gave a talk, and then I got involved in the kind of like applied statistics in open source software as such. And I think I gradually started to write pull requests, etc. And I wanted to, so that's kind of, that's where the kind of, and of course I'd already encountered Bayesian stuff at this time. So it was like, oh, this makes sense. And it probably suits me philosophically because of some exposure to it before. And does that make sense?
It's actually funny to see how all these pieces ended up fitting in together, Yeah. It's really funny. Yeah, everything is intertwined, like you picking up Bayesian statistics in practice because you had heard of it philosophically in your background, and Thomas coming to Luxembourg doing a talk, and you being introduced to PyMC 3 and so on. So it's really funny to see that.
Yeah, it is, yeah.
And since you basically, as a lot of people in this field, actually, you taught Bayesian statistics to yourself, basically, I'm wondering how long it took for you to feel comfortable, in your new field, and maybe not for you to feel comfortable in your new field, and in other words, to not feel like an imposter anymore, or at least to feel less like an imposter.
I think it's very difficult in a field like, any kind of tech field or advanced technical field to not feel like an imposter, right? So I think if it's reassuring to listeners to hear me feel like an imposter, I can tell them that's correct. That doesn't ever really go away. In terms of feeling comfortable, definitely one of the things that I think that was difficult with the whole Bayesian statistics kind of work was that like there weren't that many examples. So I think like as those examples emerge, and as I like So I put together an online course on probabilistic programming primer, which is probably mentioned in the show notes. A lot of that probably was what I carved out as the kind of minimum that I felt you had to learn to understand how to apply them. Because I think probably the secret source of Bayesian statistics is the hierarchical model, right? And if you can apply a hierarchical model, and understand how that works, which I think took me a long time because I think it's incredibly difficult. I think Bayesian statistics is in some sense harder than classical machine learning. And by classical machine learning, I mean like applying like a support vector machine. But it's also not really, because in classical machine learning, you often can delude yourself about the problem you're understanding, right? So you have to actually apply a model and get a result. I think it's faster because you don't have to do the upfront kind of thinking about the model and how you structure your data and stuff like this.
Yeah.
Which is the hard part. And I think definitely think so. Mike Benecourt a couple of years ago had a really good, one of the Stan contributors, and I've been to a number of his talks, had like a good like discussion of a modern Bayesian workflow. And I think whenever I saw that framework, I think it's probably when Bayesian stuff really clicked for me, right? So, and there's a number of other blog posts out there, by the likes of Thomas and Chris von Speck and various others. So it probably took some time. The reason I wrote my kind of course was to sort of accelerate that journey for people, because I think there's actually not that many real world examples out there. Like, of like how, like a lot of fields, you kind of got like lots of toy examples, and not a lot of like, how would I actually use this in the real world? If that makes sense.
Yeah, totally. I find interesting your comment about basically the fact that Bayesian statistics can seem harder at first to implement because you spend more time thinking about the model and have more difficulty making it run, sampling from it, etc., as compared to the classical machine learning framework. But what's really interesting there, as you said, is that first you buy some time for later in the workflow. Actually, it's thinking more deeply about your priors and your model, and the generative process of your model is actually making you save time later on when you need to think about the insights and the uncertainties and the implications of your model. And also the second aspect I see from that is the workflow aspect, as you said, which is by being able to have this principled Bayesian workflow, you can make your analysis in a way that is both easier to debug and work on and think about, and also easier to reproduce later, so to criticize also by your peers. I want to talk a bit more about, as you said, your probabilistic programming primer and so on, because I'm interested in the lessons you could draw from that. But first, I want to talk a bit about your programming journey, because if I understood correctly, you're programming mainly with Python. So can you walk us through your programming journey, basically?
I started programming whenever I was about 15. I learned some version of BASIC, and I can't even remember what flavor it was. And I was interested in building games. I was interested in building computer games. I built like pretty crappy Tetris copies. And then at some point I taught myself C badly. I got involved in kind of like modifications for Quake 3. This was also like around when I was 16, 17, something like that. Then at some point I had exams, so I had to stop doing that. And I sort of didn't really come back to programming until like graduate school or something like that, or like around my master's. And I picked up some statistics classes, and I think I learned some Python in I can't even remember how I picked it up. I think I did some kind of like summer job where there was some kind of system administration, and I think I picked it up there because there were like Perl scripts and Python scripts and stuff like this. So, like basically effectively copying files from one set, from one area to another, and running servers and making sure they were running correctly. For most of my data science work, it would have been Python and SQL as the kind of two workhorses. Over the years, I picked up some JavaScript. In my startup, I would have written quite a bit of React Native because we had mobile apps and we had React.js, we had JavaScript front ends. I'm not coding a lot at the moment. I've got too much managerial responsibilities to fit it in. And then everything else would be like backend would largely be in Python. So that's kind of my journey. I think it has some disadvantages though, because I think at various points I've probably seen myself too much as a Python programmer or something like that. And I think that's bad. I think it's better to see yourself as a developer, or a problem solver really in the larger sense, than have yourself tied too much to one language, because realistically, it's not that difficult to pick up another one, or at least be contributing to a code base, right? And I think that's a mistake I think a lot of data scientists make. So the reality is, if you want to do decent kind of graphic front end work, right? Using the likes of it used to be D3.js, but now it'll be other things. You have to write some JavaScript. So you have to be aware of the browser and how it works and stuff like this. So my advice is always to not be intimidated by any of these things and not be too tied to one particular identity, because you can add so much more value there. In the past, a mistake I've made in teams has been I've done this, I produced this analysis, but it doesn't get into a customer facing or executive facing kind of end-to-end solution, right? Like a web page, right? Which is what most people understand. Because even look at this Jupyter notebook, etc. And I know the tools have definitely got better. I'm very excited about the likes of Streamlit, etc., which looks very exciting because that kind of like accelerates some of that workflow. But I still think that not being intimidated and thinking end to end, adding end to end value, I think is incredibly important, because I think for a while there, and this is both from, in the past looking for jobs, but like now being like, kind of a hiring manager, a number of, I think, data scientists, I think we got too hung up about the whole modeling side of things and the analysis side of things, as opposed to like what we really should see our jobs as, adding kind of value to a business, right? However that is done. Does that make sense?
Yeah, okay. Yeah, I see what you mean. And it's fun to see that, you did actually a lot of JavaScripts and front-end stuff and so on. So what's your take on learning D3, by the way? I heard it's really complicated.
I think like anything, like getting just stuck in and like playing around and figuring out things. Like there's quite to learn about modern JavaScript, because you have to understand like things like, developer tools, how to debug. It's quite a complicated ecosystem, because like there's like build tools like Webpack, Babel. And then whenever you get into the whole frameworks and stuff like this, if I were to tell people to learn a front-end framework, I would probably tell them to look at something like React or Vue. I don't know if you can integrate D3 into that. You probably can. I haven't. All these things are learnable, right? So you don't have to learn them in the right order. You just learn them in some order. And I think there's a lot of good code examples out there and a lot of good resources. So I would just generally encourage people to get stuck in, because I think we can limit ourselves more than...
I'm curious also how... So you told us how you became aware of PyMC 3 thanks to Thomas Vicky. But do you remember the PRs, or maybe the first PR that you did to the project?
I can't remember exactly. I think it was some sort of documentation stuff. I think so, but I can't remember. No, I honestly, no. I can remember like writing some tests or something like that, being quite proud of that. Like I remember like the first proud PR. But there's always stuff to be done in an open source project. So
definitely.
Well, a bit like any project. I mean, something I'm very strongly believer in, that it's very easy to be like as like gatekeepers as a community in tech, like, and sort of like say, you need to know X, Y, and Z to get started, etc. But the reality is, you don't need to know all that, right? The reality is there's always something you can sort of carve off at. And I think I think PyMC3 as a community, to its credit, a lot of this is due to like Thomas and Chris, among others, has been very welcoming and has avoided like toxicity and stuff, which is, well known in other open source communities, which, we've had high profile people leave open source communities because of, people being quite rude on the internet and stuff like this. So I think that's, if there's a message people can get from that, if you're in open source community, be welcoming, be encouraging, etc. But if you want to be involved or contribute, always be aware that there is always something you can do, right? So, there's always documentation or a small test or some small feature. There are always going to be things that are more involved, like as as you get deeper into something. I think there's always a lot of stuff that can be done like that.
Definitely, I will definitely second that. Come contribute to PyMC 3, guys, and PyMC 4. We always need help, and there is always a lot to do. And as Peadar say, you don't need to contribute a new sampler to get your PR merged. There is a lot of stuff to do for everyone. So yeah. I would say the only requirement is to be at least a bit aware of the Git workflow.
Yeah.
Apart from that, it's really sky is the limit.
Yeah.
Let's talk about the course you created, actually, that you mentioned a couple of times, which is called a Probabilistic Programming Primer. And my question about that is, what are the essential skills or rules of thumb that you were trying to instill in your students? Maybe which mistakes did you notice are the most common?
The key thing I kind of built the course around was to learn how to build hierarchical models and learn how to build learn how to compare like linear regression models in a classical sense, frequentist sense with a Bayesian model, and learn how to think about priors and stuff like this. And a lot of this came from classes that I gave over the years, both at like EuroSciPy, PyData, internally at companies, when I was running my own consultancy as well. And a lot of it was based around other lecture notes that were available, like that were kind of inspired a lot of stuff. And then the questions that people came in. In terms of mistakes people make, I think it's quite like it's very easy to get like something to like not sample at all. And a lot of that is generally due to some sort of like poorly specified model. Mm-hmm. It's very easy to like kind of like pick the wrong priors and stuff like this. And I still think that's something that's relatively difficult. I noticed that like different things like APIs have improved. So like, defaults are better. And I think that has definitely improved workflows for a lot of people. And the other mistake I think people make is they probably don't plot their data enough at the start. So like, whenever I was like looking at like errors people were making, it was like applying, a distribution that made no sense whenever like a Poisson distribution would have been more suitable. And this could have been very easily resolved by actually plotting their data and looking at what the distribution was in the first place. And that's why kind of one of the things I tried to instill into the course was like the different examples people could make and stuff like this. Yeah, I guess the other thing is like people just not getting started, right? So I think that's another kind of mistake people make. There's definitely a fear or trepidation. It's seen as I think a harder subject than it actually is.
I see what you mean. Like people not going for it, like thinking too much about, should I try Bayesian Stat or shouldn't I? Maybe it's too hard. Maybe this or maybe that. Yeah.
Correct. Yeah.
Yeah, I love this kind of thinking that you're talking about. And actually, you were more generally, because you were a data science and data engineering consultant for half a decade. So
yeah,
I'm wondering about that. How did you advise companies on whether they needed to use Bayesian tools?
A lot of that would have been on the side of other jobs, like as a kind of side hustle. I did it properly for like a year or so before I set up my current company. In terms of advising them about Bayesian stuff, I mean, I think it depended on the problem. So like for a lot of like marketing problems, like our marketing analytics problems, I think hierarchical models are generally quite good because you get a lot of like uncertainty quantification, and you often have things like actual spend, and you have small data samples, right? So you have lots and lots of little small pools of data that you're trying to do some sort of inference over. And I think that suits the kind of Bayesian workflow, and I think that doesn't suit other workflows as such. You don't really get a lot of results out of that. And like in kind of like financial things, sometimes, the kind of building some sort of portfolio analysis or something like that. But a lot of other stuff was more basic, right? So I think like sometimes there were engagements where people thought they wanted a Bayesian model, but they had other challenges, like they didn't have good data or they didn't have any basic kind of like SQL queries or something like this. There was nothing to build on. And I think that problem our industry has had is that there's a lot of people looking for kind of a magic bullet when more basic methods or getting started works a lot better. And there's a whole hierarchy of machine learning notion of like you need like instrumentation, then you need analytics, and then you need like statistical models or A/B testing, and then you need like more advanced models. And I think people sometimes forget that you need to go up through all of that.
I think I see what you mean. And also I'm curious, were there like common struggles or mistakes or misperceptions you saw people in companies doing or having about Bayesian statistics and methods?
I think this is the wrong way to think about. So I think there's a very misleading, it does depend, right? So I think sometimes it's quite obvious that you need a computer vision researcher if you're in a self-driving car company or something like that, right? But I think what often happens, I think a bigger misconception is we need X, or we need this algorithm, or we need this, or whatever, right? Very, very rarely do people need a specialist in a particular deep discipline, unless because specialists are expensive. Often there's not even enough work for them, right? You might have one specialist project, which is perhaps why consultancy for Bayesian stuff can work, because you can often have like multiple companies with, similar problems. I think conversations I've had with companies in the past, or however it is, right, is like, oh, we need this, or we need this model. Often comes from like copying some Hackers News blog post that they've read about some other competitor or some other company that they admire, right? When the reality is they often don't need that, right? So I think like it's very dangerous to have a hammer and look for a nail, right? Whereas I think like actually understanding what kind of problems you're solving is far more useful, right? I think there's a lot more, low-hanging fruit for that as such. Often companies think they need a data scientist, but they actually just need a software engineer, or they need a data analyst or something like this. So I think there's a certain element of that. Does that answer your question?
Yeah, I think so. It definitely indeed resonates with some of my personal experience on the subject, at least. And actually, you wrote a book out of all these experiences, which are interviews with
data scientists.
Exactly.
Yeah.
Interviews with data scientists throughout the world. And so I'm curious, can you tell us about that? And by the way, I will put the link to this book in the show notes, because all the money goes to the NumFocus organization, which is the umbrella organization under which PyMC, for instance, is under. So people, you can go and buy the book if you want to support NumFocus and PyMC.
So I definitely think like one of the motivating reasons behind the whole, someone who rode the kind of big data wave, etc., is there's definitely a feeling of like, why has this company hired me? What is my job? How do I add value as a data scientist, etc.? There's that kind of question. And the reality, I think, was from those interviews was, I think a lot of people were running into similar problems, right? So I was just interested in like what people had seen, whether the same challenges were there. And I think there's like kind of like two things came across there. I think there's kind of a fundamental challenge for any kind of so definitely like there are companies who hire data scientists and don't need them. Like that definitely came across in the interviews and came across like kind of offline, and I reached out to various people, and that was helpful for building up a network, right? So there was a certain element of networking that came out of that. And it was interesting to see different verticals and different applications and stuff like this. And it's funny how like although it's a couple of years back, I mean, a lot of that stuff hasn't changed, right? I still think we're very much at the earlier days of machine learning or professional application of data science. I think the biggest issue is probably cultural. I think a lot of people say they want to be data driven until something goes against what they actually want to do. So management wants to do something and then it's like a contradiction, and then they're like, oh no, I'm going to do what I want to do anyway. Takes a certain element of intellectual honesty to do that otherwise. And I still think our tools and stuff are like, there's still like a lot of process and tools that we don't really have yet, right? So I think we have like kind of good workflows for doing professional software engineering to some extent, although software engineering is still a difficult art. I still feel like in professional machine learning or professional data science, I still think we're working it out, a lot of it ourselves. It's like there is still no data science product management framework as such, or even like decent workflows and stuff. Although that is improving and people are kind of like aiming at the same kind of stuff.
Definitely super interesting. Actually, I'd like to talk about your new adventure now, because we're talking about stuff that you did in the past since the beginning of the show. And it's super interesting because then you have some also had some time to think about that. But before doing that, I have maybe a last question related to all the modeling work that you did, and that I often ask my guests. And it's whether you have a favorite model or method, one that you're always happy to use and can share with us.
Always happy to use, or one that I think people don't think enough about?
Well, maybe both.
Always happy to use... Oh, it's probably going to be something like a Bayesian general linear model or something like that. It's probably going to be like a Bayesian GLM or a Bayesian logistic regression. In terms of like classical machine learning models, it's probably going to be a random forest. But in terms of a statistical model that I wish people would use more, and I know people have been saying this, some people have been saying this, Eric Bernardson's been saying this, and so has Cameron Davison-Pylon, is survival analysis, right?
Yeah.
A lot of problems in industry have censored data, right? So a lot of problems in industry, like loans, so like you don't have all the information about the loan expiry date. I used to work in fintech, and that was a common problem then. In my own work, like running a tech startup, like you'll often have stuff about marketing, right? So you'll have like a marketing campaign, but you won't necessarily know the end result of that marketing campaign. You might only have a few months data, right? So like the kind of a survival analysis model works pretty well there. And even like cases about churning from a subscription model, right? Like churn models are almost not very actionable, but like kind of survival analysis model could be a lot more actionable there. So I think survival analysis models are definitely a modeling framework or paradigm that I don't see used enough, but should be, because a lot of stuff applies to those sort of use cases.
Original. I didn't hear about this advice, but very thoughtful. And so, yeah, people use more survival analysis.
Yeah.
Yeah, these are actually very interesting models. There is now with modern PPLs like Stan and PyMC and Pyro, NumPyro, etc.
Yeah.
All these Galaxy, there are really good tools now to do some Bayesian survival analysis. So yeah, very, very nice.
Yeah.
Okay, let's talk about Aflorhythmic now. Do I pronounce it right?
Yeah, that's correct.
Yeah, okay.
Yeah.
Aflorhythmic is the startup you co-founded.
Yeah.
I'm guessing, if I understood correctly, that this is more about AI than Bayesian methods, but can you walk us through what you guys are doing?
Our company is doing personalized voice as a service. So it's probably worth like clarifying what that means.
Yeah.
Our users often use us to do like personalized audio messages or personalized audiobooks or some sort of like short, like automatic podcast generation. And so our workflow is text to speech. So that's where the AI comes into it. So at the core, there's, synthetic text to speech models such as WaveNet, WaveGlow, which are, deep learning models. And by the way, there's a whole galaxy of models like that, right? So, WaveNet and WaveGlow are just two examples, but there are various other ones. And we sort of dynamically generate content. So like maybe make that a bit more concrete. Some of our customers are like coaches, and they use it to send like automatic, like welcoming on web pages to their clients. Hi Alexandra, here's your daily update. Hi Peadar, here's your weight loss tips, etc. Whatever, depending on whatever vertical they're in. So it's kind of like, if you want like a slightly geeky way of viewing it, you can kind of think of it a little bit like mail merge for audio. So like, in the same way you might have like personalized email marketing, we're doing personalized audio in the same kind of sense. So yeah, we don't use any Bayesian methods at the moment. I'd expect that to be changed in like maybe the next year or so. But the reality is that whenever you're building a company is that there's a lot more software stuff to be built at the start. Like first you build the product, then you get the data, and then you can do the kind of like AI stuff, unless you have a particular core like use case like we did with like, needing like better synthetic voice models. So there's like a premium in improving the core algorithms.
Of course, I'm curious about the podcast part. How does it work? Because you were saying automatic podcast generation. So for instance, what does it mean?
So basically you write some text into a tool or call our API. You add in some sort of personalization parameters, whether it's name, location, whatever, and then we generate audio based on that. I think podcasts will still exist. I don't think any text-to-speech technologies will change that.
Mm-hmm.
But I think something that's fundamental, though, is that there are a lot more use cases where audio suits, right? So like when we commute, when we walk, there are various cases like, the whole rise of smart speakers. There are various cases where like having some sort of audio version of existing text is helpful, right? So there's a whole kind of thing there. And that's definitely one thing we've seen, like particularly on the marketing side, right? So it's hard to get, screen time. There's a lot of evidence as, and you see this in service, etc. The screen time is getting, people staring at a screen is getting lower and lower. And there's various day-to-day lives where, audio can be helpful. So making audio bigger than just podcast creation, podcast hosts is kind of one of the kind of vision things that we've been thinking about.
Yeah, very interesting. This is definitely kind of futuristic even. So I really love this project. And actually, we're getting short on time, but let me ask you another question about that, because I saw that your technology can also be used to help with loneliness, with personal and mental health, and with childcare. So I'm curious about that. What can you tell us?
On the childcare side, we've done some pilots or work on like children's stories, like turning stories into children's entertainment. So that's kind of like childcare thing. In terms of loneliness, we have a partner who's exploring how audio can be used to alleviate loneliness, particularly in the elderly. So one challenge that kind of comes up is like things like scheduling messages, or kind of a concrete example is people who are in. So a concrete example is people who want to send kind of like audio reminders or audio greetings to family members, right? So there's a certain element of like, personalizing it, adding, dynamically generating that content or whatever. And there's also like kind of advantages in that space of phones, for example, are quite sophisticated technology, whereas audio, particularly if people have accessibility issues, is particularly suitable, right? If someone's used to a radio, there's no reason why they can't be used to some sort of like voice first interaction with a kind of a device. So that's kind of what they're exploring there, but that's one kind of early days project, which I'd love to talk more about in whenever there's a bit more of a fruition or success stories with that.
Yeah, but that's definitely super interesting and inspiring to see these kind of projects going on.
I think something that is underestimated, I guess this is probably the kind of last thing I could wrap up with, is it's very easy to get cynical about technology. And it's very easy to say things like, oh, so what do you do? Oh, I just work on a website, or I just work on an app, or I just work on this, right? But the tools we build, and this is like from my tool builder hat, the tools we build, like, so PyMC 3, which we've both been involved in, has had a material impact on the lives of numerous people around the world, because numerous major companies have used it in applications, and this is being used to make better decisions, and this is being used. And I think we underestimate the importance of building good tools and the effect good tools have on people's lives.
Oh yeah,
that's I think an underappreciated thing. And it's easy to think, oh, we're just working on this or whatever like this, but there's a whole, the whole notion of like, the Stripe company I have a huge amount of respect for. They talk about like raising the GDP of the internet, and they sort of talk about how the internet is just getting started, etc. And I think that's largely true, right? I think we underestimate how much impact we can have in terms of what we build for, the thousands or millions of people who could potentially be impacted by our work. So it's good that you say that you find that a little bit inspiring, but I think it is something that we should think about more, right? We can have, tremendous impact on people's lives. So that is one of the reasons why like being involved in professional machine learning, being involved in statistics, building tools, building companies, I think is incredibly important. So in the words of Mark Anderson, it's time to build.
Yeah, I really agree with that. And that's actually, it's not the same scale, but that's actually also an aspect I really love in open source development. It is that you encounter an issue or you are thinking about a new feature that could be helpful not only to you, but to the whole community. Then you develop it, you merge it, you get it merged into the project. And then it's awesome to see people using it, and then asking questions on the discourse or stuff like that. And you're, oh, that's great. That I developed that feature and people are using it. So I'm guessing they find that useful. That I find it really, really awesome because, as you say, it makes your life easier in the end and makes the life of a lot of people easier. So that's awesome.
Cool.
Okay, well, that was a super interesting conversation, Peadar. Before letting you go, though, I have to ask you the two questions I ask every guest at the end of the show. So the first one is, if you had unlimited time and resources, which problem would you try to solve?
Climate change.
Yeah. You're in good company here. I think Thomas Vicky answered that, and also Junpeng Lao. So
I expect Junpeng to answer that as well. Yeah.
You would do a great team there. And second question is, if you could have dinner with any great scientific mind, dead, alive, or fictional, who would it be?
This one I'm sort of conflicted by. So part of me wants to say Einstein, part of me wants to say Feynman. So there's definitely a physics thing there. But actually, Alan Turing, because I think the foundations, so much of his work was so his life is incredibly tragic, as those of you who've seen the movie or read his books about him. But also, like, he was so far ahead of his time. So it's incredibly, with quite premature methods, that it's interesting to kind of talk to someone like that.
Yeah, good choice. And I think you're the first one to pick Alan Turing. So well done on that. It seems like you guys are going to be only two at the dinner, so that's great.
Yes, yeah.
Well, Peadar, thank you very much for taking the time. Very interesting to talk about Bayesian methods in industry, how they are used and misused, maybe sometimes. I'm always happy to see how PyMC 3 is used concretely. And also, as I said, I think you guys are doing a fascinating job with Afrorhythmic. So good luck with that. And as usual, I put resources and a link to your website in the show notes for those who want to dig deeper. Thank you again, Peadar, for taking the time and being on this show.
Thank you very much.
This has been another episode of Learning Bayesian Statistics. Be sure to rate, review, and subscribe to the show on your favorite podcatcher or on Podchaser, and visit learnbayesstats.com for more resources based on today's topics, as well as access to more episodes that will help you reach true Bayesian state of mind. That's learnbayesstats.com. Our theme music is Good Bayesian by Baba Brinkman, with MC Lars and Megaran. Check out his awesome work at bababrinkman.com. I'm your host, Alex Andorra. You can follow me on Twitter at Alex_Andorra, like the country. You can support the show and unlock exclusive benefits by visiting patreon.com/learnbayesstats. Thanks so much for listening and for your support. You're truly a
good Bayesian. Change your predictions after taking information in. And if you're thinking I'll be less than amazing, let's adjust those expectations. Let me show you how to be a good Bayesian. Change calculations after taking fresh data in. Those predictions that your brain is making, let's get them on a solid foundation.